years, engineers struggled to design a new lock and dam here on one of America's busiest waterways. If they had shut down the locks while they built the new dam, they would have cost the U.S. $2 million a day. So engineers had to find a way to build a new dam without closing the waterway. They went back to the drawing board and finally came up with a radical proposal: to construct the dam in the wet.
Trying to eliminate use of cofferdam.
Instead of building a massive dry construction site in the middle of the river, they prefabricated sections of the giant structure on land. Then floated them out into the river, where the buoyancy made them 10 times lighter. Then they assembled them like Lincoln logs. The same method could be used to build the Panama Canal's new Atlantic locks. But the canal's new Pacific locks face a different problem. Powerful ocean tides. Twice a day, the tides at the canal's Pacific entrance rise and fall 22 feet, putting enormous pressure on the gates of the locks here. To cope with this pressure, the engineers had to build gates that are the tallest and strongest on the canal. But the gates for the new Pacific locks must be almost twice as big, nearly as tall as a 10-story building.
Well, I think that's the most difficult thing, in my opinion, is the lock gates, because they are quite complicated steel structures.
Jose Reggae and his team decided that they could come up with a better design than the type of gates now in place on the canal. That type of gate works like French doors that swing open and closed. Instead, Reggae chose a design that's in use today in Antwerp, Belgium, in what are currently the world's largest locks. They're known as rolling gates because they roll into place across the lock chamber from a pocket in the lock wall. Only inside do you get a sense of what a monster this Belgian gate is. 2/3 as long as a football field, 7 stories high, and 60 feet wide. It makes Panama's lock gates look like the doors of a dollhouse. In dry dock, this gate weighs 1,500 tons, as much as 5 Boeing 747s. But as heavy as each of these gates is, it would be just half the weight of the proposed new Panama rolling gates. How will engineers roll a 3,000-ton gate across the 200-foot wide lock? They won't have to. As this model shows, the buoyancy of the water reduces the effective weight of the hollow gates to a mere 100 tons. But before any designs can be approved, they must be tested using scale models in labs like this one in Mississippi, run by the Army Corps of Engineers.
Working here at the Corps' research lab has really been enjoyable for me. Oftentimes we have been accused of being big boys with big toys, when it really is a lot of fun, especially when we see something that we help design and make a lot better.
Engineers test how well the new locks will fill up and empty under heavy water pressure. The new lock design must allow water to rise evenly and calmly, or the results could be catastrophic for a real ship. The threat of an accident is never far from the minds of the canal's engineers and pilots like Dave Sherman. He's about to guide the tanker through the final set of locks near the canal's Pacific entrance. canal crossing has cost the tanker's owner $295,000 in tolls. But that's a whole lot cheaper and safer than taking the long way round. But before engineers build a shortcut for the new megaships, they're going to have to solve one more problem. This one could be the killer. What will power the locks? Water is the engine that drives every lock system. But Gatun Lake doesn't hold enough water to lift the megaships through the new locks. Engineers must solve the water problem, or their dreams of enlarging the canal for the new supercargo ships will die. They are exploring three options. One is to reduce the number of chambers in the lock from 3 to 2. Fewer chambers will save water. But one less chamber also puts the drinking water of millions of Panamanians at risk. That's because currently, salt water entering the lock chamber closest to the ocean gets diluted by fresh water in 2 more chambers. Removing one chamber means that more salt water may enter the lake. But there's another possible way to solve the water problem. Create a new lake by building another dam on a nearby river. But damming the river would mean flooding thousands of homes. And that's too high a price for the Panamanian government. Luckily, there's a third option, currently in use in Germany. It's called a ship lift. Instead of raising the water level in the lock chamber to raise or lower a boat, they actually lower or raise the lock chamber itself. After a boat enters the chamber, gates on both ends are closed off, so the boat is now in effect floating in a bathtub. The chamber is then raised or lowered to the next water elevation. The gate at one end opens, and the boat continues its journey. The best part is that no water is wasted. But these boats weigh 1,000 tons, a mere 1/60th of the ships in the Panama Canal. Engineering a lift mechanism strong enough to lift one of these ships would be beyond extreme. But there is another method of using water in the locks that may turn out to be the answer. A system of holding tanks that recycles water. When a ship wants to transit from a higher elevation to a lower one on this German canal, engineers release water from the top lock chamber. But instead of just spilling out into the river, the water flows into a nearby holding tank. Then, when another barge needs to be raised to a higher level, engineers can use the recycled water in the holding tanks. If engineers can build a similar set of holding tanks for Panama's new locks, they might be able to lift and lower the new megaships with just the same amount of water that's now used in the old locks. But even if engineers can solve the problem of water power, they must still confront a terrifying natural threat that could overwhelm all their efforts. Earthquakes. Panama has recently been experiencing an increasing number of tiny earthquakes. Earthquakes occur when geological plates grind against each other. Panama lies dangerously close to 4 of these massive plates, but has not been hit by a major quake since 1882. The new increase in seismic activity could actually be a good thing. Evidence that the plates are safely releasing built-up pressure. But these little tremors may also be the first warnings of a killer quake to come. The most dangerous effect of any quake would be to damage the Gatun Dam.